Hi, I'm Andy Manthei with Truemont Materials, and I wanted to take a little bit of time to tell you about a really interesting project we completed recently. It's called the Bayard Street River Stabilization Project. This was an important job for the city because in past hurricane events, the end of this dead-end street were blown out, and eventually they had a 12-foot vertical cliff eroding away at the end of their roadway. So what we wanted to do is provide a product that would allow them to build a gravity wall system that would provide the most drainage through this wall section so that we could prevent hydrostatic pressure from building up and causing failures in the future. Redi-Rock was the answer. Let's dive into the design and installation of this retaining wall. This wall is 12 feet tall and runs 90 feet along the river, with return walls on each side to prevent any scour from behind the wall sections if the adjoining walls of the neighboring properties were to fail. The bottom half uses our massive Redi-Rock XL blocks, 3 feet tall with 52 and 72-inch depths. The top half is made of our 41-inch hollow core and 28-inch PC blocks, topped with the 28-inch top block with a curved finish, allowing for grass to grow right to the edge of the wall. These huge precast modular blocks form a gravity retaining wall that needs no geogrid reinforcement and can support the weight of heavy equipment directly on top of the wall. The most critical feature is the maximum drainage this system allows. The entire wall sits on a crushed stone leveling pad with a 1-to-1 stone wedge of drain stone behind it. The stone is wrapped in non-woven geotextile fabric, allowing water through but keeping soils out. The hollow core blocks are also filled with stone, and because the blocks are dry stacked, meaning there's no mortar between these joints, the design engineer has decided to use these joints to draw water from behind the wall. All these factors work together to relieve hydrostatic pressure during major storms and reduce rapid drawdown effects from flood events and tidal fluctuations. Finally, to prevent scour, the bottom block is placed below the scour line, and riprap and stone were laid at the wall's toe to break up wave action and stabilize the soil. This ensures the wall will stand the test of time in an extremely aggressive environment. And finally, let's talk about the installation process. The installation of this wall starts from the bottom up. First, a small berm and a kelly well kept the trench dry. Non-woven geotextile fabric lined the trench base for the crushed stone leveling pad. Once compacted, the base course of blocks were set. Each block has a lifting hook, allowing an excavator to quickly set and adjust the units. Native soils were dug out for the 1-to-1 stone wedge, and more fabric was laid before bringing in the drain stone. Stone is compacted in lifts behind the wall and used to fill the hollow blocks. Fabric is also placed at the vertical seams to keep small stones from migrating through the face of the wall. The cast-in-place collar around the stormwater pipe was built by epoxy coating and drilling rebar into the surrounding blocks, forming a strong connection. A wood form was then built and concrete was poured in place around the pipe. These modular blocks are built from the bottom up until they get to the top course. Here the fabric was wrapped over the top of the stone wedge and soil was laid right up to the top edge to allow for a grass finish. The wall and cast-in-place collar were completed in just 1 week. This fast installation allowed the crew to move quickly to the streetscape work. In the end, the city of Green Cove Springs got a retaining wall that will stand the test of time and look incredible for decades to come. So, if you're looking to design or install a retaining wall in your market, be sure to give Truemont Materials a call today. We'd be happy to help.